syllabus. Welcome to my channel, Learning Builds Life. Today we are going to talk about indices. Let's take a look at today's sum. Prove that x to the power of a plus b by x to the power of c whole to the power of a minus b until x to the power of c plus a by x to the power of b whole to the power of c minus a until x to the power of b plus c by x to the power of a whole to the power of b minus c equal to 1. Let's do this. Here, LHS is this entire expression and RHS is 1. We have to prove LHS equals RHS. LHS equal to, now we have to copy down this entire thing. X to the power of a plus b by x to the power of c whole to the power of a minus b until x to the power of c plus a by x to the power of b whole to the power of c minus a until x to the power of b plus c by x to the power of a whole to the power of b minus c. We have copied the LHS down. Now we have to solve this. Okay, firstly, we have to use this property that if it's like p to the power of m by p to the power of n, it is equal to p to the power of m minus n. Keeping that in mind, we get here x to the power of a plus b minus c whole to the power of a minus b, and the same thing we apply for the other two, x to the power of c plus a minus b whole to the power of c minus a until, here we again do the same thing, x to the power of b plus c minus a whole to the power of b minus c. Now that we got this, we can apply another property that if it's like p to the power of m whole to the power of n is equal to p to the power of mn. And p to the power of mn after we get p to the power of mn. So here also we have to apply the same thing. Here we get x to the power of a plus b minus c whole into a minus b the whole into x to the power of c plus a minus b, this bracket looks like, yes, whole into c minus a the whole, into x to the power of b plus c minus a, whole into b minus c the whole. Now what can we do here? How can we do this easily? If you look at these, then underlining this now, in the next step we can write equal to x to the power of a plus b the whole into a minus b the whole minus c into a minus b the whole. We get that? If we check, then if we take common factor here, common factor is a minus b, and we are left with a plus b and minus c, so it's giving back this form if we check. Then we can do the same thing in case of the other ones. Into x to the power of c plus a into c minus a the whole minus b into c minus a the whole. We do that, and then here also the same thing. X to the power of b plus c whole into b minus c the whole minus a into b minus c the whole. Now let's do further calculations here, and here we can use identity that if it's a plus b to a minus b the whole equal to a squared minus b squared. Keeping this identity in mind, we get, and also using that identity as well as we will use distributive method to distribute this multiplication. Let's do all of that together and then let's see what we get. Here we have x to the power of a squared minus b squared minus ca plus bc. Here into x to the power of c squared minus a squared minus bc plus ab into x to the power of b squared minus c squared minus ab plus ca. Bringing all of that together, we get x to the power of a squared minus b squared. Means here we have to use another identity, which is if it's like p to the power of m into p to the power of n, it's equal to p to the power of m plus n. Then from there we get a squared minus b squared as it is, ca minus ca plus bc plus, here c squared minus a squared minus bc plus ab plus b squared minus c squared minus ab plus ca. This is the entire exponent, but don't worry, this will all get simplified now. This is very easy. Check carefully. A squared and a squared can be canceled here. B squared and b squared can be canceled here. C squared and c squared can be canceled here. Minus ca plus ca can be canceled. B plus bc minus bc can be canceled. And finally, ab and minus ab can be canceled. We ultimately get x to the power of 0. And we know if anything is to the power of 0, it's 1. And 1 is equal to our RHS. So we could prove that LHS equal to RHS. This is proved. Now we may take a look at the board. Hope you enjoyed this episode, and please like, share, and subscribe to my channel, and stay tuned for more videos. Thank you.